Hello everyone and welcome to 6 coordinates on the coordinate plane with proving quadrilaterals. So today's topic is kind of interesting. It really involves us taking everything we've learned so far and understanding all the properties. So you can see that this first page just has a recap of all the properties on it. I'm not going to go through it because you can go back and watch the other videos in case you need to, but you can see all these properties here were built into this nice, beautiful, wonderful sheet that you can look at and reference. So I'm gonna go ahead and just go on to this next page where we actually need to read how we're gonna do this. So when we're classifying quadrilaterals, it's really two major steps that we gotta focus on. The first one is we wanna find the lengths of all the sides using the distance formula. And from that we can determine a few things. Based off if they're congruent or not congruent, we can figure out what's going on. So if you have congruent sides, we know that what's gonna happen is either we have some sort of a parallelogram, if both are congruent, or we have an isosceles trapezoid if one pair is congruent, or we have a kite if two pairs of consecutive sides are congruent. If none of them are congruent, well, all we can check then is whether or not we have a regular trapezoid or just a regular a plain quadrilateral, nothing special about it. So you can kind of see what we're doing here. So if two pairs of consecutive congruent sides, we know we have a kite, right? So if those sides that are congruent happen to be next to each other, it's a kite. If that's not the case, we may need to find the length of the diagonals to see what's going on, because at that point, if we have congruent sides, but they're opposite, so one pair of opposite sides is congruent and congruent diagonals, that's when we know it's an isosceles trapezoid, right? So we only have one congruent side. And after that, we would say, well, if we have two pairs of opposite sides, again, this is where we know it might be a parallelogram, but the diagonals are not congruent, well, at that point, you really have only two options. Either it's just a parallelogram, or it could be parallelogram, or it could be a rhombus. But from there, you could really figure it out. If it's a parallelogram, just the opposite sides are congruent. If it's a rhombus, all the sides are congruent, right? I totally spelled those words wrong. Let me just try that again. Parallelogram and rhombus. Missed the U. All right, and if two pairs of opposite sides are congruent and the diagonals are congruent, that point we're gonna have, oh, I see what they did. Actually, this is just the rhombus. Sorry. This is the parallelogram. The rhombus is gonna be down here. This one, if you have two pairs of congruent sides and the diagonals are congruent, at that point it's a rectangle. And then down here, I see that what got put in here. So if all four sides are congruent and the diagonals are not, then it's a rhombus. And if all four sides are congruent and the diagonals are congruent, it's a square. And looking at this last part, sorry, I was cut off. If you happen to find that none of the sides are congruent, well, all you have to check then is the slopes. If one pair of opposite sides is parallel, then it is a trapezoid, not an isosceles trapezoid, just a boring plain trapezoid. Otherwise, it's simply a quadrilateral. I know that seems like a lot there to take in, but really you're just paying attention to your properties. You're finding the length of all four sides and deciding what it could be. And from there, you're checking the diagonals potentially, or you're checking the slopes. It just depends on what situation you have. So let's take a look at the examples we have. We have these three examples. So my first one. Example 1, classify a quadrilateral with the endpoints A, B, C, and D with the coordinates there. If you wanted to draw this on a coordinate plane, you could, just to kind of see what you're expecting to happen. But that would definitely take a lot more work than we necessarily need to. What we want to do, though, is we want to find the distance between all 4 points. So AB, BC, CD, and DA. So what I'm going to do is I'm going to set up my little, I'm going to do my distance formula a little bit different. So I'm going to put this here and this here. If you were in my class, you definitely have seen me do the distance formula like this. If you're not, it's the same thing, but if you want to use that distance formula, that D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, all that square rooted. Same formula, I'm just gonna do it in little chunks. So what I ask myself is how far apart is -1 and -3? Well, they're 2 units apart. And how far apart is -2 and -4? Well, they're 2 units apart. So I just plug that into the Pythagorean theorem, a squared plus b squared equals c squared. So I get 2 squared plus 2 squared equals c squared. I get 4 plus 4 and we'd add that up and get 8 equals c squared, square root both sides. We get that the square root of 8 equals c. You could get that decimal if you wanted to. I'm not even worried about it, though, because you're going to see that we don't really need to know. The next thing we need to figure out is what b to c is. So b is the point -1, -4. C is the point 4, 0. And again, we say to ourselves, how far apart are those? So how far is -1 from 4? Well, that's 5 units. -1 to 0 is 1, and then to +4 is 4 more. -4 to 0 is 4. So I'm going to end up with 5 squared plus 4 squared equals c squared. 25 plus 16. And when I add that together, we get 41. And then I'm just going to do it all at once. Put the square root over it. So square root of 41. Next, I've got c to d. C is 4, 0. D is 7, 6. Space them out. 4 to 7 is 3 units. 0 to 6 is 6 units. 3 squared plus 6 squared. I get 9 plus 36. So I end up with the square root of 45 for C. And last but not least, we're going to do D to A. So D is 7, 6. And A was -3, -2. So those are going to be 10 units from each other, whereas these are going to be 8 units because they're on opposite sides of 0. So I end up with 10 squared plus 8 squared, 100 plus 64. So 164 square rooted. So what we can see is I have 4 different sides. So I know it's not a parallelogram. It literally can't be any parallelograms because they have opposite sides at least equal, or all 4 sides equal. It can't be an isosceles trapezoid because isosceles trapezoids have 2 equal sides. And it can't be a kite because kite has 2 pairs of consecutive equal sides. So the only possibility is that it maybe it's gonna be a trapezoid if one pair of sides is parallel. So I'm gonna need to find the slope between all of these. So the way that we find slope is we actually kind of go back and rethink these problems. Instead of, I just kind of asked myself how far apart they were. I didn't really worry about the spacing. We can use the formula if we need to. So in this case, we're gonna do y2 minus y1 over x2 minus x1 and see what we get. So here, y2 minus y1, -4 minus -2 is +2, so we get -2. And then -1 plus minus -3 is going to be -1 plus 3, so I get +2, so I get -1. Do the same thing here. You see kind of what's happening. We're just subtracting upwards. 0 minus -4 is 4. 4 minus -1 is 4 plus 1, so 5, so I get 4/5. Here I've got 6 minus 0 is 6. 7 minus 4 is 3, so I get 2. And last, I've got -2 minus 6, which is -8. -3 minus 7 is -10. That would be -4/5. So these are almost the same slope. They're opposites of each other, but that's not good enough. They had to be exactly the same, so I know that this is just a basic quadrilateral, nothing special. In example 2, same idea. We're going to start off the same way and do all of our distance formulas. So I'm going to start with S to T. ST is -9, 14 and 110. So the distance between those is 10 units. And the distance between 10 and 14 is 4 units. So I get 10 squared is 100 plus 4 squared is 16. That's 116. And since this is c squared, we know that we have a square root of 116. Next up, we got T to U. TU. T is 110. U is -3, 0. So I've got 4 units apart here and 10 units apart here. Ooh, 4 and 10. I just did 4 and 10. We know the answer then. It's going to be the square root of 116 again. You don't have to do the math again. It's the exact same answer. 10 squared gives me 100. 4 squared gives me 16. Same thing. Next, we got U to V. U is -3, 0. And V is -13, 4. That's going to be 10 units apart and 4 units apart. Look at that. That's the same number. Same thing. Okay. Last, I'm going to do V back to S. VS. V is -13, 4. S is -9, 14. Here I've got 4 units apart. Here I've got 10 units apart. So again, we get square root of 116. So all 4 are the same. So there's only 2 options. The only shapes that we learned, quadrilaterals we learned with all equal sides, is squares and rhombus or rhombi. The easiest way to figure out then is the diagonals. If the diagonals are equal, it's a square. If the diagonals are not equal, it's going to be a rhombus. So the diagonals are going to be the other letters. So we did S to T, T to U, U to V, V back to S. Skip the letters now. So S to U is one diagonal. So -9, 14, and U is -3, 0. That's going to be 6 units apart and 14 units apart. So I get 36 plus, I don't know, 14 squared off the top of my head. Let's see, 14 squared, 196. And then add our 36 in there, and we get 232. So the square root of 232 is equal to C. And T to V is going to be the other diagonal. So T is 110, V is -13, 4. Those are 14 units apart. Those are 6 units apart. Those are the same numbers. I know what's going to happen. I'm going to get the same thing. So if the diagonals are also equal, this has to be a square. And bringing us home with this last example here, same thing. You always start out with your 4 distance formulas. So W to X, X to Y, Y to Z, and Z back to W. So WX. I've got 2, 4, 3, 6. So that's going to be 1 unit apart and 2 units apart. So 1 squared plus 2 squared equals C squared. That's going to be 1 and 4, so I get 5 when I add them together. So the square root of 5. X to Y. X is 3, 6. Y is 6, 4. That's 3 units apart, 2 units apart. So I'm going to get 9 plus 4, which is going to be 13 square rooted. So I got square root of 5, square root of 13 so far. All right, X to Y, so we got Y to Z next. Y, Z. Y is 6, 4. Z is 3, 2. I got 3 units apart, 2 units apart. I've seen that number already. That was down here. Square root of 13 again. And last, Z back around to W. So Z is 3, 2. W is 2, 4. That's 1 unit, 2 units. I saw those numbers too. So that's going to be square root of 5. So you can see what happened here. The middle 2 are equal, and the outside 2 are equal. So if you needed to draw the picture, you could, but it would look like this. W, X, Y, Z. These 2 are equal, and these 2 are equal. So it has to be a kite, because the consecutive sides are congruent. So a lot of work there. They do take a little bit of time, but with practice, you're going to get it, and you're going to be awesome at it. So thanks so much for watching. Let us know if you have any questions, and we'll see you in class. Bye, y'all.